Professor Bialis here. In this video we're going to be talking about section 3.5, which is equations of lines. We've dealt with graphing lines a lot in this chapter, but now we're going to look at the algebraic aspect of it. So what we're going to start with is introducing different forms of the equations of lines. Now each of these forms have their benefits, have their drawbacks. Okay, so let's get started with the most basic general form that's called point-slope form. Okay, so again, this is section 3.5, equations of lines. Okay, and as I said, first one is point-slope form. Okay, now point-slope form goes like this. Given the slope m and any point on the line, we are going to denote with x1 and y1. Okay, the equation of the line is y minus y1 equals m times the quantity x minus x1. Okay, now there was a lot to take in. Let me go through that. Given the slope m, so we talked about slope before. Remember, slope is that rate of change, rise over run, whatever you want to call it. Okay, but we have a slope m. Every line has a one unique slope. Okay, it's not going to change from different parts of the line. Okay, so you have the slope of the line and you have any point that's on the line. Now remember, 2 points determine a line, but there's always going to be an infinite number of points on a line. So what's really good about this is that we can very easily get into this equation. Okay, because we don't need very specific information. We need the slope, but then any of an infinite number of points on the line. Okay, now this x1, y1 is just to keep these two variables different. You got the y, you got the y1. When we're plugging these values in, they are going to be going into these spots right here. The regular x and regular y stay open because when we build these equations, we always want to have that x and y variable in there. Okay, so I like to think of these ones as kind of like a little keyhole that allows you into that spot. So real quick, let's just do a quick example of this. Let's say I have a line with a slope of 1/2 and it goes through the point 3, -4. Okay, so that's a line. We've got a slope and then a point 3, -4. Okay, now if we were going point slope form, whenever you're using a formula, write it out so you remember it, and then we're going to plug in. So we've got y minus, and then the y coordinate of the point. Now notice it's a -4. So if there's a minus and then you plug a negative on top of that, it turns to a +4. Equals m is 1/2, and then x minus 3. That's all there is to it. It really is plug and chug. Now notice on these coordinates from the point, it was -4, now it's +4. It was +3, now it's a -3. Always look for that opposite relationship between the numbers in the ordered pair and the numbers you plug into the equation. Okay, so we will do a little bit more of this when we get into examples in a couple minutes. One other thing though that I want to point out with this is where this is coming from. Okay, now remember slope formula. Which was given in the previous section as that. Okay, now first of all, why do we have the 2 and the 1? All that is for the first point, second point, and really to keep those two y's separate, to keep them unique. So couldn't I also keep them unique by just taking those 2's away? I can still tell the difference between the y's and the x's. Okay, now given this is a true equation. Watch what I'm going to do. I'm going to clear fractions by multiplying both sides by that denominator. And what do I end up with? This is the same as this. So I don't want you to think that this is some random formula that someone just just made up off the top of their head. All this is a manipulation of the slope formula that was established in the past. Okay? So what's really nice about this, again, is that it is so easy to get into. You don't need specific information to get that done. Now, let's look at another form of an equation of a line. This form is something we've talked about already, and that is slope intercept form. And that is your good old y equals mx plus b. And remember, this m, as always, is your slope, and your b is your intercept, but specifically your y-intercept. Okay? What's really nice about this, as we've seen in the previous sections, is that this is so easy to graph with. Okay? In the textbook, they talk about graphing this with this in section 3.5 in this one. I covered that in my section 3.4 lecture. Okay, so if you do want to have a little bit more explanation on this, there were a couple examples in section 3.4. Okay, but again, this is a very nice graphable form. And what makes this kind of when you know that it's in this form, you have y by itself. Simple as that. Now, the last form is nice because it's very clean. Okay, and this is typically how we introduce lines or linear equations, and that is in standard form. And standard form you should recognize from previous sections. That is your ax plus by equals c, where a, b, and c are just real numbers, so there's really nothing specific about that in a linear equation. But when you're specifically in standard form, we want a, b, and c to be integers. Okay, so what that means is a, b, and c, there cannot be, so no fractions or decimals. Again, if we were just defining a general linear equation, then a, b, and c could be anything. They really can. But when we specifically want to be in standard form, we have that layout of x and y on the same side, but also we cannot have any fractions or decimals. The reason for that is, again, we just want to make it a clean, nice version of the equation. That's all. Also, a needs to be bigger than or equal to 0. Okay, what that means is you cannot have a negative on the x term. Again, the reason for that is we don't want to lead with a negative because it's not as nice. Some books, including this one, honestly do not follow this rule. Okay, however, it's never considered wrong if you do follow the rule. So I always tell my students, just follow the rule, make it as nice as possible. It's never going to be considered wrong. It may be considered wrong in some situations, in some books, with some teachers, if you put a negative out in front or leave a negative out in front. Okay, so that's why I would just suggest make it positive. You don't have to worry about it. Okay, so these are your three main forms of a linear equation. This one's easy to get into. This one's nice to graph, and you'll know you're there when you have a y by itself. And then to get into standard, we are going to have x and y on one side, but then no fractions or decimals, and the a has to be positive. Okay? In this section, there will be some problems where they tell you find point slope form. Then you're done. Find this, find that. Then you go to whatever form they're asking for. In our discussion here, I am always going to go to standard form because you're going to see when we go for standard form, we're hitting all three of these in one shot. Okay? So let's look at some examples here. Let's say I want to find the standard form of the line. And I have a line that has a slope of 2/3 and goes through the point -3, 7. Let's say we have that. So there's a slope and there's a point. Now what we're going to do is, given a point and a slope, start with point slope form. These are not clever names, okay? So if you have a point and a slope, point slope form it is. I'm going to start with the y minus y1 equals m quantity x minus x1. Write it down so I remember it, and say it so that it gets kind of a rhythm in your head. And then I plug in. So it's y minus the y coordinate equals the slope, then x minus the x coordinate, but minus -3 is really a +3. Okay? Now, after this, I want to get all the way down to here. Find slope-intercept form next, meaning solve for y. Okay, so what I'm going to do is I'm going to distribute to get y minus 7 equals 2/3 x, and then 2/3 times 3. Imagine a 2/3 right here. Those 3's would cancel out, so we just get +2. And then complete the solving for y by adding a 7. And there's your slope-intercept form. If the instructions were, put this in slope-intercept form, you're done. But if we want to go to standard, we don't do anything different up until this point. We just keep going. So for standard, there's 3 things. First of all, get x and y on the same side. So I'm going to subtract 2/3 x to get -2/3 x plus y equals 9. The next thing is, we can't have any fractions or decimals in there. So we need to clear that fraction out. So I'm going to multiply everything by 3. And then lastly, that coefficient on x, cannot be negative. Okay, so what I'm going to do is I'm going to multiply everything by a -1. Really, for all practical purposes, all we're doing is changing all the signs. So what we get is a 2x minus 3y equals -27. And there is your standard form. Now, could we have, up here, move the x first, then the 7 if we know we're going for the standard form? Yes. However, I like to practice this routine by finding point slope, then slope intercept, then standard. So we have that in our head that we are getting all 3 forms. Whatever form they ask for, we know how to get. If we kind of bypass this slope intercept and we always go to standard once I ask for slope intercept, then we have to change our routine. I want to keep this very regular. And by doing it this way, you're not adding any steps. We might be doing it in a different order than you would want to, but it's not requiring any additional steps. Okay, so it's not any more work, and then they're doing it this way, you're getting all 3 forms. Okay, so as you can see, I wasn't doing a lot of crazy stuff. I was just solving an equation, and I was hitting these benchmarks along the way. Okay, nothing too crazy. However, there's a lot of algebra going on here. When I give this chapter 3 test, what I typically see is, a bunch of pages where everything is perfect. And then we get to this page and it's just covered in red. And the reason for it is not because, we forget these formulas. It's because we just get lost in all this algebra. Okay? So that's why I want to keep it very routine. So that's the same. I distribute. I bring over the constant. I bring the x back. I clear the fractions. I change the sign. That's never going to change. That's never going to change. Do it the same way every time, and then you don't have to worry about, okay, what do I do next? Let's look at another example. Let's say we have now, I give you a little bit of different information here. I want the standard form of the line that goes through those 2 points. Now, this right here, I like to call this the gateway equation because it kind of gets you into an equation to begin with. But in order to use this, I need a point and I need slope. I don't have the slope yet. So the first thing you need is to find that slope. And that brings us back not to this, but to the slope formula. So what we're going to start with is that y2 minus y1 over x2 minus x1. Okay, so we've got second y minus first y, second x minus first x. 8 minus 2 is 6. 8 minus 6 is 2. Reduce that to a 3. If I was graphing, you might want to write it as a 3 over 1 because then you see the rise and run. But since we're just going right into equations, honestly, I would just leave it as a 3. So here's your slope. Okay, now we are going to jump into point slope form. Okay, point slope form requires any point and the slope. So which point do we use? You use whichever one you want. Okay, if you really like the number 6, then use 6 comma 2. If you like the fact that they're both 8s in the other one, then use 8 8. Use whichever one. Okay, I'm going to show you both just so you can see what that would look like, but you only need to use one of them. So if I use 6 2, it would be y minus 2 equals 3, and then x minus 6. That's if I was using that 6 comma 2. If I was using the 8 8, then my point slope form would be this. Both of those are correct. Okay? Now, regardless of which of these you use, the rest of the way should be the same. Okay, so let's go and put this into points or a slope intercept form. So I'm going to distribute to get that, and then I'm going to add a 2. And there's my slope intercept form. Okay, now again, just for the sake of argument, for the sake of discussion, let's do this one as well. Let's see what we get. Okay, it's different than what we had over here, but when I do this, we have exactly the same thing. Again, you do not need to use both. I just wanted to show you that whether you use the 6-2 or the 8-8, you're going to get the same result eventually. Okay, so don't think, well, I got a different answer. I must have used a different point, so that's why it's different. It's okay. If you have a different slope intercept or a different standard form, something went wrong. Okay, there's only one slope intercept and one standard form for each line. There's point slope form. There's literally an infinite number of versions of that are all correct, depending on what point you use. So let's go with this one. If I want to do the standard form, I'm going to bring the x over. That gets the x and y on the same side. Now the next thing I got to worry about is I can't have any fractions or decimals. Well, there aren't any, so I'm good. But the x coefficient, that a value, has to be positive. So what I'm going to do is I'm going to multiply everything by a negative 1. 3x minus y equals 16. And there's your standard form. Okay? So again, I distributed. I brought that constant over. I brought the constant over. I then brought the x over. I brought the x over. Here I had to clear fractions. That wasn't an issue, but I would have done that next. And then I changed the sign. It's the same thing. And when you're studying this, what's good about math is that one procedure can literally be used an infinite number of times. You need to know one procedure, and you can do an infinite number of things with it. Okay, so when I'm studying this, I'm not saying, okay, distribute 2/3. 2/3 times 3 is 2. I'm not looking at those specifics. I'm saying to myself, I'm distributing. I do that here, I do that here. I move that constant term over. Keep it general so that you can apply it to anything and everything I throw at you. Okay? Let's look at another one. Okay, I always have students ask, can we go over a fraction one? Well, here we go. Okay, so we have 2 points, same as before. We need to find the slope. So let's do that. So when we're finding the slope, we got that y2 minus y1 over x2 minus x1. The second y is 1/13 minus the first y of 0. Second x is negative 1/8 minus the first x of 0. Now, that's kind of a scary expression right there, okay? But don't think too much about it. Remember, fractions mean division. Nothing more than that, okay? So let's take this one piece at a time. Anything minus 0 is still that original term. Same thing here. Oops. Okay, now I have a 1/13 over negative 1/8. I could also say 1/13 divided by negative 1/8. Okay, from there then, when I divide fractions, I multiply by the reciprocal. After that, 1 times negative 8, 13 times 1, there's my slope. Okay? So again, I know fractions can be scary, but if we break them down one step at a time, one piece at a time, you'll be fine. Okay? Over here, don't look at this and say, I got to do all that. No, one piece at a time. Okay? That's like saying, I want to, get a doctorate degree. If you think of it that way, that's a lot. Or I want to get an associate's, that's a lot. Okay, I want to get a certificate, that's a lot. But if you think of, I have this class that I'm in right now, that's manageable. Then the next thing, I got this class, that's manageable. And before you know it, you're done. So one step at a time. So there's your slope. Now, we're going to go to point-slope form. Remember, point-slope form can use any point on the line. We're given 2. Which one do we want to use? Okay, they're both correct. Don't use that. That's going to be a pain in the butt. Use this one. Okay, neither of them would be wrong, but sometimes there's a better option. Okay, one is better than the other. I'm going to use 0, 0. So I've got y minus y1 equals m quantity x minus x1. And I'm going to use the 0, 0. So it's y minus 0 equals negative 8/13 x minus 0. Now what's nice about this is all those zeros just kind of go away. You don't need to write those in. So we have y equals negative 8/13 x. Okay, now that is your slope-intercept form. Sometimes people want to put that plus 0 there. If we're not graphing it, I really wouldn't bother with it. Okay, but it's not going to hurt. If you want it there, you can write it in. Okay, so then I go to standard. The steps I need to follow, I need to first get the x and y on the same side. Don't forget about that 0. A lot of people, they just want to put the equal in between there or something like that. That side on the right was emptied out, so now there's a 0 value there. Now, the only thing I need to fix here is that fraction, so I'm going to multiply everything by a 13. And there you go. Okay? So again, even if there's fractions, even if the numbers get ugly, just take your time, focus, trust the process, and it'll work out just fine. Okay? Now, there is one other type of line, and you might be kind of thinking what to expect right now. I want to talk about. Let's look at how this is going to come out. Let's say we have 2 points, 5, 7, and 5, negative 8. Okay, a point through those, or a line through those 2 points. Same as before, got to find the slope. Okay, so if we find the slope, we're going to have the second y minus the first y, the second x minus the first x. Okay, now let's calculate that. Negative 8 minus 17 is negative 15. But then 5 minus 5 is 0. Now don't leave it like that because that needs to be simplified. Anything over 0 is what? Undefined. Now, here's the thing. If we think, oh, I'm just going to go point slope form, you can't plug in undefined. Even if you plug in negative 15 over 0, you can't do anything with that. So we just have to know what this is. If we think back to that slope section, section 4, when we had an undefined slope, what kind of line was that? That was a vertical line, okay? So since it's an undefined slope, I know it's a vertical line. When it's a vertical line, these kind of go out the window. There is another form of the line. And any vertical line we've had in the past always had an equation of x equals some number. Now, what number do we pick? What's the only x value they give you? The only x value they give you is 5. And that's your equation of the line. That's it. Okay, so something that we need to kind of add to this list. If we have a vertical line that is a slope that is undefined, and the equation of the line would be x equals some constant c. There are 3 pieces of information here. If you know one of them, the other 2 are going to happen. If I know it's vertical, automatically, slope undefined, here's my equation. If this is my equation, automatically, the slope must be undefined and there's my graph. Okay, those all go together. What if I give you something like this? Okay, again, 2 points, we would find a slope. So the slope is first y minus second y, or I'm sorry, second y minus first y, and then second x minus first x. If you switch the y's and you do the first minus the second, that's okay as long as you do the same thing on the x's. Just stay consistent with which one you start with and you'll be fine. So what we get here is 0 over negative 5. Okay, now this is a little different because 0 over negative 5 isn't undefined. That just simplifies to a 0. Okay, now 0 can be plugged into here and you can work that out. But save yourself the headache. If we have a slope that's 0, what kind of line was that? There we have a horizontal. Okay, so I know it's a horizontal line. All horizontal lines had equation y equals, and look, what's the only y value they give you? 6. And there's your answer. So another set of information. If I have a horizontal line, the slope must be 0, and my equation is y equals some constant c. Okay? Again, you could plug in the 0 here and it'll work out to the y equals 6, but it's not necessary as long as you know what that 0 means. Okay? There's only one other type of problem I want to do a few of to make sure that we're clear, and it involves these vertical and horizontal lines. So again, I want to find the equation of the line, but it's going to say this. It's going to go through the point, let's say, negative 7, 11, and then you are parallel to x equals 2. Okay, so now we're taking those equations of lines and pulling in that parallel, and it's going to be a perpendicular as well. I'm going to show you an example of that. So if I have parallel to x equals 2, remember what determined parallel and perpendicular. All that was the slope. So by saying they're parallel, they're telling you what the slope is. Parallel to x equals 2. X equals 2. If it's x equals a number, it's vertical. If I'm parallel to this, I'm also vertical. So I'm looking for a vertical line. If it's a vertical line, the equation must be x equals a number. What is the only x value they give you? This is a different line. This is just what I'm referencing. This point is what I am going through. So if I'm x equals, the only x value I know is negative 7. That's it. End of story. Okay? Now, what about through, let's say 5, -12, and perpendicular to x equals 7. Okay? So, again, x equals 7. What kind of line? Vertical. But if I'm perpendicular to this, I have to be horizontal, okay? Giving you that right angle. So now I'm looking for a horizontal line, therefore my equation is y equals. What's the only y value they give you? -12. There's no work to show on these, but we have to stop and think. And if that means you have to sit at your table or desk, wherever you're at, and say, okay, if I'm parallel, if you have to do that, do it. Just think about it. Don't just jump into it. Okay, the quick ones, we want to make even quicker. We want to just look at it and boom. But if it's going to be a 15-second thought process, take the 15 seconds. Don't push it and try to, try to make it into a 3-second process, because that's when mistakes happen. Okay, so that's pretty much it. There's a lot of algebra when we're dealing with this. Just take your time and you will be fine, okay? But know these targets. Know the targets and make it as routine as you can. Look at, okay, I distribute, then I bring the constant over. That's how you should be talking through this and anything that we cover in mathematics. Keep it general and you can apply it to anything and everything you want, okay? So, as always, work hard. Let me know if you have any questions, and I'll see you next time.